This is the budding light of hope and knowledge, the delight of Sri Prakash Educational Institutions, spreading academic brilliance in all directions.
Namaste all, this is N.S.R. your class 10th mathematics teacher. In our today's session, we are going to continue with our chapter 2, sets. In our previous session, we learned that a set is a well-defined collection of objects, and we know that George Counter is the father of sets. We also discussed about finite sets, infinite sets, subsets, universal set, and different types of sets. We all know very well that in arithmetic, we are going to have 4 fundamental operations like addition, subtractions, multiplications, and divisions. In the same way, the sets also has 4 fundamental operations, which are also known as basic operations on sets: union, intersection, and difference between two sets. In our today's session, we are going to learn about the basic operations on sets in detail. Let us continue with our today's session. In this session, we will continue with our chapter 2, sets. Recalling the definitions of sets and the types of sets, introducing union of two sets and their Venn diagrams, illustrating union of two sets with Venn diagram, defining disjoint sets, and determining the difference between two sets are the learning outcomes of our today's session. Dear students, follow the given below instructions. Keep your pen, the textbook, and a notebook with you. Watch the video and listen to the audio till the end. Make a note of the content. Share your tips and questions in Google Classroom. After watching the video, complete the worksheet. We have a clear action plan to realize our learning outcomes today. We'll start with the vocabulary task. We'll recall the basics of sets. We'll introduce the basic operations on sets. We'll learn the procedure of illustrating basic operations on sets through Venn diagram. We'll discuss some applications on basic operations on sets. Before we enter our further exploration, let us discuss today's word. Our word of the day is composed, which can be used as an adjective and also as verb. As an adjective, composed means to be made or formed from several things or people. As verb, composed means calm and in control of your emotions. The verb conjugates of the word composed are compose, composed, composed, composing, composes. The textbook usage of the word composed is: the set of irrational numbers is composed of all real numbers which are not rational. M.M. Keeravani has done a great composition of music. Adi Sankaracharya composed Saundarya Lahari. The composite of shopping malls, houses, and roads created a new town. Who is the composer of National Anthem? We are done with our vocabulary task. Let us continue with our lesson. Let us recall the basics of sets. A set is a well-defined collection of objects or ideas. It was developed by George Counter. As we have discussed here, there are some collection of objects are there: 0, 2, 4, 6, 8, 10. Therefore, this is called as a set. The numbers in the set are called as the elements of the set. If a set has number of elements, then after writing the number of elements, if a set has infinite number of elements, then we will write the first 3 elements of the set followed by 3 dots, which indicates that the set itself has infinite number of elements. If a set has only countable or finite number of elements, then we will write it in this way. If a set has infinite number of elements, then we will write it in this way. How can we write a set? There are various ways in which we can write sets. For example, we have to write the set of all vowel letters in English alphabet. Then we can write that as V is equal to A, comma, E, comma, I, comma, O, comma, U. This way of representing sets is called as roster form of writing sets. Here in the roster form, we list down all the elements of the set between curly brackets. All the elements of the set are written and separated by commas. Here you can observe that this is a set A in which the elements are 1, 2, 3, 4, 5, which indicates the natural numbers from 1 to 5. The elements are written between curly brackets, separated by commas, and every set should have a name, and that name should be a capital letter. There is another way of describing a set. For example, we have to write the same set of all vowel letters in English alphabet. We can also write that one as X such that X. For such that symbol, we can use the semicolon or slash. X such that X is a vowel letter in the English alphabet. X such that X is a vowel letter in the English alphabet. What we have done here? We described a set by using the common property of all the elements of the set. That is why this type of describing a set is known as set builder form, in which we write the set by considering the common property of all the elements of that particular set. Now let us discuss about some types of sets, and the first one we are going to discuss is empty set. A set which does not contain any elements is called an empty set or a null set, are also called as void set. Empty set is denoted by curly brackets with no elements in them, or it is denoted by a separate symbol which is called as null. Now let us discuss about finite and infinite set. If it is possible to count the number of elements of the sets, or if a set contains a finite number of elements, then those sets are called as finite sets. For example, factors of 6, 1, 2, 3, 6, it has only 4 factors. So the factors of 6 is a finite set. If it is not possible to count the number of elements of a set, or if a set contains infinite number of elements, then it is called as an infinite set. For example, multiples of 6. What are the multiples of 6? 6, 12, 18, 24, so on, which is infinite. So that multiples of 6 is a best example of infinite sets, whereas factors of 6 is a best example of finite sets. Cardinal number. The number of elements in a set is called the cardinal number of that set. For example, if you observe, there is a set A in which the elements are -2, -1, 1, 3, 5. That means this set has 5 elements. So the cardinal number of this set A is called as 5, and which is denoted as n of A. Here the second example is given. X such that X belongs to n, and 3 is less than or equal to X is less than 7. That means what are the elements that are in set A? They are 3, 4, 5, 6. That means the cardinal number of this set is 4. We already discussed about 2 ways of representing a set, and now there is another way of describing a set which is known as Venn Euler diagram, or simply it is known as Venn diagram also, in which a set is described by using circles and a rectangle. Do you know what this rectangle represents? Yes, this rectangle represents universal set. Here in the diagram, you can observe that this part is a different part of A, this part is a different part of B, whereas this part is same for A and B. Now, let us discuss about the first basic operation on sets, that is union of sets. The union of sets A and B is the set which consists of all the elements of A and B, and the common elements being taken only once. This is the symbol which is used to denote the union. We will write like this, and we will read it as A union B. And the set builder form of A union B is X such that X belongs to A or X belongs to B. In the diagram, this first circle represents set A, and this second circle represents set B, and this part represents the elements that are common in both A and B. So the entirely it was shaded, that means the entire part which is shaded represents A union B. Let us discuss some more details about A union B by an example. Let us consider a set A in which the elements are A, B, C, D, E, and another set B in which the elements are D, E, F, G, and then find A union B. Here we have A union B is equal to A, B, C, D, E, which are the elements of A, D, E, F, G, which are the elements of B, but we have to observe that the common elements that are D and E was taken only once while we are writing A union B. The same is explained through Venn diagram for your better understanding. Here D and E are common, that is why they are written here. These are the different elements of A, these are the different elements of B, and the final answer A union B is equal to A, B, C, D, E, F, G. There is one more example. The question says that A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5, 6. Show that B union A is equal to B. Have you observed any difference between the set A and B? Yes, it is very much clear that all the elements of set A are also in set B. That means A is the subset of B. If A is a subset of B, then the union of sets A and B is the set B itself. If A is a subset of B, then B union A is nothing but B. Here you can find that the set B with the elements 1, 2, 3, 4, 5, 6 and set A with the elements 1, 2, 3. Then the result of A union B is equal to 1, 2, 3, 4, 5, 6. Now there is one more example which will clearly explain you what is A union B. Let us consider A is equal to 0, 1, 3, 5, 8 and B is equal to 2, 5, 8, 9. Then see here, this first circle represents set A in which the elements are 0, 1, 3, 5, 8 and the second circle represents set B in which the elements are 2, 5, 8, 9 and A union B is nothing but by writing 5, 8 which are common only once, we'll get A union B is equal to 0, 1, 2, 3, 5, 8 and 9. And as usually this rectangle represents universal set and this is the symbol. If you write, this is the way of describing the union of two sets by using Venn diagram. Now the second operation on sets is intersection of sets. In general, the intersection of sets A and B is the set of all elements which are common to A and B. That is, those elements which belongs to A and also B will be considered in A intersection B. This is the symbol which is used to denote A intersection B and we will read it as A intersection B. Symbolically, A intersection B is written as X such that S belongs to A and X belongs to B. The intersection of A and B can be easily explained in Venn diagram as shown in this figure. This first circle represents set A and this second circle represents set B. Now you can easily find that the shaded part which is common for both A and B is called A intersection B. Now let us go through one more example. Find A intersection B if A is equal to 2, 4, 5, 6, 10, 11, 14, 21 and B is equal to 1, 2, 3, 5, 7, 8, 9, 11, 12, 13. And now you can easily find that this blue circle represents set A and this yellow circle represents set B and this common part of A and B is highlighted as pink in which the elements are 2, 5, 11. That means these are the common elements in both A and B. That is why A intersection B is 2, 5 and 11. There is one more example is given for you for better understanding of A intersection B through Venn diagram. By this, what are the elements of A? 1, 2, 3, 4, 5. What are the elements of B? 1, 3, 9, 12. Why you have written 1 and 3 here? Because this 1 and 3 are common in both set A and set B and this part represents our A intersection B. When we are practicing the intersection of two sets, we'll get a doubt. What do we call if there are no common elements in set A and B? Here is one example is given for you. There is a set A in which the elements are 1, 2, 3, and there is another set B in which the elements are 5, 7, 9. Then you can find that there are no common elements in A and B. Such type of sets in which there are no common elements are known as disjoint sets. Here you can find that A intersection B is equal to null. This is the way of representing disjoint sets by taking two separated circles in one rectangle. Now let us see an example. Here if you observe, there is a set A in which the elements are 1, 2, 3, and there is another set B in which the elements are 5, 7, 9. You can easily find that there are no common elements are in A and B. That is why A and B are disjoint sets. Now there is another set C in which the elements are 3, 5, 7, and there is another set D in which the elements are 7, 9, 11, where we can find there is a common element in C and D. That is why here C and D are not disjoint sets. The last and final operation on sets is difference of sets. The difference of sets A and B is a set of elements which belongs to A but do not belongs to B. We write this as the difference of A and B as A minus B, and we will read it as simply A minus B. The set builder form of A minus B is X such that X belongs to A and X does not belongs to B. In this diagram, you can easily find that there are two sets A and B, and the highlighted part, the common part that belongs to only A is highlighted, which represents A difference B. Let us learn some more things about A minus B by using a Venn diagram. Let A is equal to 2, 3, 4, 5, 6, 7. B is equal to 3, 5, 7, 9, 11, 13. And find A difference B. If you observe, this is set A and this is set B. You can easily find that 2, 4, 6 are the only elements that are only in A but not in B. That means 2, 4, 6 are the elements that belongs to A difference B. Now, if you observe the previous diagram, we can find that 9, 11, 13 are the elements in B. That is where they are not taken into A difference B. Similarly, for B minus A, the elements which are only in B will be taken. That means from the same diagram, A is equal to 2, 4, 3, 6, 5, 7. And B is equal to 3, 5, 7, 9, 11, 13. But here the elements 9, 11, 13 are only in B. That is why they will come to B difference A. Note that A difference B and B difference A are not same. Let us summarize what we have discussed in our today's session. In this chapter, we have studied the following points. A set which does not contain any elements is called an empty set or a null set or a void set. A set is called a finite set if it is possible to count the number of elements of that set. The number of elements in a set is called the cardinal number of the set. The set builder form of A union B is equal to X belongs to A or X belongs to B or X belongs to both. The Venn diagram of A intersection B is written as X such that X belongs to A and X belongs to B. The difference of two sets A and B is denoted as A difference B, which means only the elements of A, with B difference A, which means only the elements of B. Well students, hope you understood the basic operations on sets and the procedure of representing the basic operations such as union, intersection and difference in Venn diagram. This is the last video of our chapter 2 sets. In our next session, we are going to start our new chapter, chapter 3 polynomials. Let me conclude our today's session with a small question. List out the sets A and B and their elements such that A and B are disjoint sets. Give 5 examples of two sets which are disjoint sets. Submit your doubts and queries in Google Classroom. We will meet in the next session. Till then, thank you all.